To teach periodic tables, I don't use a periodic table. Because periodic table, even the word periodic, people go, oh, I don't understand. And you show them a periodic table and they go, I don't understand. So I start off with, whoa, what's water made out of? And most of my students, when I'm going around the class, I'll get half of them maybe going, oh, H2O. What's the O? In H2O, it's in air, it's 20% of air. Now, so I'm using their answers and then giving them back with more information, confirming what they've said is correct, or correcting it, or getting someone else to correct it, even better. So that the knowledgeable students are appreciated by the ones that don't have the knowledge. And so this gives a positive feeling in the class for knowing stuff. Now what's the H in H2O? There's two of them. Now, so there I've just said, oh, the little two means that there's two hydrogens and one oxygen. There's two of them and only one oxygen, H2O. What's the H? And then there might be a bit of guessing, and I'll get somebody to say hydrogen. Oh yeah. Reactive gas, explosive gas, hydrogen, and once you've exploded it in air, you get tiny amounts of water. And scientists noticed this, and this is where they found out that water wasn't an element. They used to think water was an element, back in Greek times, and 400 years ago, before Dalton and his friends, they used to think water was an element because they couldn't break it apart. Now we have electricity, we can put two electrodes into some water, bubbly, bubbly, hydrogen comes off here, oxygen comes off here, the anode and the cathode. One gets the hydrogen, the other one gets the oxygen. So long as the water isn't pure water, 100% pure water doesn't conduct electricity, but hey, put your hand in there and suddenly you've put loads of salts in there. Or if the beaker's been used before. Anyway, most water conducts electricity, including salt water from the sea. It will give you hydrogen and oxygen using the anode and the cathode. So now we've got hydrogen. I'll put H on the board, and I'll put one by it. And I won't explain what that one's for. Next one I'll ask is, what is the gas that makes your voice go squeaky? They all have seen those YouTubes. Yes, it's helium, and then someone's going to ask me why. And I will say, well, great scientists in the past had a go at the answer to this question. And if you look it up in Google, you'll see, the speed of sound in helium is faster. True. And this makes the pitch go up because there's more frequencies per second. Well, if that was right, it would be working and it would be a good answer, but we found out it's not. It's actually that the high-pitched sounds are, yes, moving faster, coming through better than the low-pitched sounds. And that's called timbre. Timbre. It's a musical thing, so you need a musical person who teaches science. Really, the science isn't very well explained. It's so complicated for such an easy question. Anyway, helium. Well done. Let's not get into the complicated and wrongly written down stuff on Google. Hg. Now I'm going to put H here and Hg there, away from one another. Why? Because one's reactive and one doesn't react. It doesn't react with oxygen, it doesn't react with anything, never reacts. It's called a noble gas. And the noble gases we're going to put here, another noble gas in the air, 1%. It's used in light bulbs, the old-fashioned ones with the wire in them, to stop the light bulb reacting. I said they don't react, see? So it's a gas that doesn't react, and it's in air, so therefore it's free. Just like oxygen, it's nice and cheap. So hospitals have oxygen to help you survive COVID. It was run out in India. They ran out of oxygen because actually you have to cool down the air to make the liquid oxygen, and then you can split the liquid oxygen from the liquid nitrogen from the liquid argon. Oh, I said the word. Then if I'm thinking the students aren't going to get me a word like argon, which isn't a commonly used word, even though it's 1% of air, I'll put it underneath helium, some way underneath, leaving a gap for neon. And then I've got to talk about neon. Neon lights, they're the red. Well, lots of people think they're green. They're the red fluorescent tubes, again, old type of lighting. We've now got LEDs, they're much better. And I hate halogen light. Oh, halogens. Oh, I've said halogen light bulbs. They're the ones that really hot people have little dots of them in their kitchen. They're very bright. They look great. Designers love them. They're really bad for the environment because they give out even more heat than the old-fashioned filament light bulbs with a wire inside and loads of argon. And I talk quite quickly so that my students are trying to keep up all the time. Keeping it interesting, going slower and faster and higher tempo and lower tempo. And that way you keep your students involved, and also keep your students involved by, asking them, what would you do with this argon? Hold on a minute, 2 minutes ago I said what we did with the argon. Can anyone remember? I'm going to write it on the board. And then people are given credit for concentrating. And they know that, hey, anything Mr. Stevens said can come up in 5 minutes' time, and it's a good mark in your book. Not your book, my mark book. And those good marks in my mark book, can I write it down? They constitute how I write my reports at the end of the year, because otherwise I've got to remember who answered all the questions in class. I think it was him, but now I've got evidence, and I use that evidence during the teacher and parent evenings. So now I've only done hydrogen, helium, neon, argon, and explained their differences. Now I have to explain lithium. But to get lithium involved, I go, what's the battery in my mobile phone made of? Well, it's not entirely lithium, but hopefully someone's going to know lithium, and if they don't know, I'll just let the secret out. So it's lithium. So we put lithium underneath here, underneath hydrogen, and now I'm saying, look, this is how Americans make a periodic table. Which is okay, because hydrogen gives away 1 electron. That's why these two are in group 1. And lithium gives away 1 electron. These two are in group 1, because they give away 1 electron. And hey, what things like calcium and magnesium? Oh no, I've given away 2 more elements in my periodic table. I have to write them up now. Calcium in your bones and magnesium in the magazines of automatic weapons, especially for the Americans. And you just get, people remember stuff if you add automatic weapons, magnesium, and light lithium, because it's the lightest of the alkali metals, group 1. Now, with Americans having hydrogen here on top of lithium, we've got grey metal, grey metal, grey metal, grey metal, grey metal, and then a gas. So that's why the rest of the world puts hydrogen kind of on its own at the top, floating around on the top of the periodic table. So these are now all grey metals that give away 1 electron. An electron is a tiny little piece, floats around on the outside, makes electricity, and on the outside of each atom. And now, so now I've introduced the fact that there must be more grey metals that give away 1 electron. One of those grey metals is the major salt metal in salt water, seawater, in salt. So if you look at salt and you're American, it will say low salt, but the rest of the world, mostly. What's the salt in salt? And you might get somebody going sodium chloride and go, yes, sodium Na. See, sodium should be SO. Why is sodium not SO? Because it was discovered by a German gentleman, and this German gentleman called it natrium. And I went to a lecture in Germany. It was about astronomy, but he was going on about sodium being natrium. And afterwards I asked him, why is sodium called natrium? And he said, because it's natural. And I said, yeah, but hydrogen, helium, argon, lithium, they're all natural. And he goes, is natural. And I went, oh, okay, don't hear me. Okay, so that's why they call it natrium, because it's natural. 92 natural elements in the periodic table, but that's the one they wanted to call natural. That's why it's Na, because a German gentleman discovered it. And the one underneath, a German gentleman also discovered, because Americans are getting too much Na, too much sodium in their diet. And you do need sodium. Sodium's how your nerves work, all the nerves in your brain that send thoughts backwards and forwards, and also that go ow from your hand to your brain when you touch something sharp. All of those nerves, those messenger thin wires called neurons, all of those have got sodium and potassium. And they're both in group 1. Oh, I've told you about potassium. Anyway, it doesn't matter. Potassium. Now, potassium was also discovered by a German gentleman, so yes, it's not P. But we can use potassium to, well, there's a connection with Harry Potter. Harry Potter? Yes, because Harry Potter's ancestors, because his name was Potter, his ancestors made pots. And the ash from pots is a great place to find potassium. If you want to get a whole bunch of potassium, and 200 years ago you're an alchemist, not quite a chemist, but an alchemist, then, yeah, dig around in the ash for pots. You'll get loads of potassium. Put it on your crops and your crops grow better for food. So, potassium is called kalium by the Germans. And I need someone German at that point. So if I've got someone in German in the class, I'll go, okay, tell me why potassium's called kalium, because I can't remember it. The lecture was 30 years ago. And probably they won't know. But just asking them makes them think about it. And everyone's getting the word said several times in several different contexts. And that's how students remember something. So kalium, oh, well, what letter of the alphabet should we use as a symbol for potassium then? Should it be P-O? No, because it wasn't discovered by an English person the first time, even though we named it something different. No, kalium, K. So they're going to get K. Hopefully they get K. These are the only ones in the entire periodic table. There's lots more down here. There's francium down the bottom. But francium is... it's so rare. Well, it falls apart. When you've got 1 gram of francium and go, look, I've got 1 gram of francium. I'm the richest man in the world. I can just afford 1 gram. Oh, no, it's half a gram now. It falls apart very quickly because the amount of protons and neutrons are offset protons. So anyway, this 1 and then 2 and then 3 for lithium is the number of protons. All hydrogens have 1 proton. It's a little ball shape in the middle. It's like a positive thing, like a positive attitude. So, yes, hydrogen's got 1 positive thing and 1 negative thing running around. So I'll draw that on the board. And about this time, my lesson's beginning to end. And I'll say, look, there's loads more. Next lesson, in even my tutorials, over the internet, 1-to-1, in people's homes, or in my lessons, I'll say we'll go over all of this next time. Make sure you've got it all written down. And hopefully that will encourage people to write things down as I go. I like people writing, looking up, listening, hands up, responding, getting marks, writing things down. Always working, always thinking. If you look at something with your eyes, you learn it once. If you write it down, it has to go through your hand, through your nerves, to your hand, and you're looking at it 3 times through your brain, and then I'm going to make it a 4th time. Next lesson. How to slowly build up the periodic table. And then the next lesson, and then the next lesson, we'll talk about more and more of the elements. If you just present, boom, over 100 elements on 1 diagram, people switch off. It doesn't work. And then you get neutrons involved, saying, look, there's types of hydrogens that make atomic bombs called H-bombs because they've got more neutrons. The sun is a continuous set of H-bombs going off. They're 1 proton, so therefore they're a type of hydrogen with 1 neutron. So they're a heavier hydrogen. 2 neutrons called tritium. With 1 neutron, it's called deuterium. And so therefore I'm getting protons, neutrons, electrons slowly put onto them. And the next lesson, if they remember that positive protons is like a positive attitude, we have to then come up with 2 positive attitudes and 2 negative attitudes for helium. And we'll slowly build the periodic table. That's how to teach.